Good afternoon, everyone. Thanks for tuning up, either face-to-face in Rocky here or online or watching this recording. Okay, I'll move myself here. This is week 6 of MATH11246, Essentials of Applied Mathematics. We start with acknowledgement of country. We respectfully acknowledge the traditional custodian of the land on which we work and learn. We pay respect to First Nations people and their elders, past, present, and emerging, for they hold the memories, the tradition, the cultures, and hope of Aboriginal and Torres Strait Islanders people. Aboriginal and Torres Strait Islanders people should be aware that this course may contain images, voices, and names of deceased person. Okay, so this is what we did last week. When I say last week, I would say last session because it wasn't last week, it was a week earlier. We talked about equation, linear and quadratic, and the general properties, multiplication and division of algebraic fraction, solution of linear equation, quadratic equation, characteristic formula that minus b plus or minus square root b square minus 4ac over 2a stuff, system of linear equation, more than one equation, solution of system of linear equation, elimination and substitution. We talk about back substitution then. And then dependent and inconsistent system of equation. Dependent is the same, right? One on the other one. And inconsistent system of equation. By that we mean the parallel lines. Yeah. Good. And practical application of linear equation. We talked about the salt and water mixture, alcohol and water mixture, all that kind of thing. Yeah. The 10 cents, 2 cents kind of total coin, their value, all that kind of questions. Right. So we will review triangles and trigonometry, which is chapter 2 from the prescribed book. Plane angles. So any angle of these forms, they will be referred as a plane angle, right? The angle is always considered with the positive x-axis. So that's your 0, and that is the positive x-axis, right? As you can see here, that's the x-axis, the y, x dash or negative x, y dash or negative y. Okay. Plane angle means the angle in two-dimension angle. Many theories to suggest it anti-clockwise, right? So one is the positive x-axis and the positive y-axis, right? So when you go from here to the positive y, it's considered as the anti-clockwise. We know how clock works, right? Right. There is one more theory why it's considered that way. The Earth rotates counterclockwise or anti-clockwise when viewed from the North Pole, stars Polaris. The solar system was created from a disk of material that began to rotate counterclockwise, that is anti-clockwise, as we know it today. Because of the conservation of angular momentum, the sun and the planet spun counterclockwise as they formed from the material. Right? So this is everything about why we keep it counterclockwise. To make it simple, just adopt it. That we say that they are counterclockwise or anti-clockwise. It's the same thing, counterclockwise, anti-clockwise, right? Right. So there are two ways of measuring it, the angles in terms of radian and degrees. As we know, we have a couple of units of measuring distance. How many on top of your head? How do you measure distance? Kilometer, yep. And then you go miles, feet, yeah. But mostly feet and miles is US system, yeah. We talk about centimeter and meter or kilometer in Australia and majority of the world, yeah, right. But we need a bridge between them, isn't it? We should know that 1 mile is about 1.6 kilometer. Yeah, you need a bridge. 1 feet is 30 centimeter. So we need to fill a bridge between two different systems. Same thing goes with CGS and MKS system from your high school study, right? Centigram, gram, and second. MKS is a meter, kilometer, sorry, meter, kilo, and second. Yeah, so you need a conversion between those two, right? Okay. Why that's relevant here? Because here we're talking about conversion of radian and degree. There are two different measures that you will study. 2 pi is 360 degree, pi is 180 degree, or pi over 2 is 90 degree. Why is that? How do we come up to this relation? Does anyone know that? Why is 2 pi 360 degree? Anyone?
Circle.
Circle, very good. What's about circle?
So two half circles make 360.
Very good. And how is it connected with 2 pi? Right. So remember the circumference of a circle or the perimeter of a circle is 2 pi r?
Oh.
Right. So what happened? When you draw a circle, right, you started from this point and you went all the way and came up here. The circumference is 2 pi r. Now we always talk about unit circle. So r being one unit. That unit could be centimeter, meter, kilometer, miles, 1,000 kilometer, nautical mile, light year, whatever, but one unit, right? So this circumference then is referred as 2 pi. Now, how much degree have you covered in this? So this is 90, another 90, the third 90, and the fourth 90. So you covered 4 times 90 degree, or saying that is 360 degree as well. And therefore, you got 2 pi as 360 degree, pi as 180, and pi over 2 is 90. That's the connection between the pi, which is a real number, we call it the radian as well, and the degree, right? So from here, if I say pi is 180 degree, therefore, if I divide it by pi, 1 r means radian is 180 over pi. That's the relation here, okay? And now pi is 3.159 approx. When you divide it, you got 1 radian as 57.296 degrees. And similarly, if you need a degree, is pi over 180, and that's for 0.017453 radian.
Sorry, I didn't quite understand the radian aspect. What was a radian again?
Radian is a real number. It's just another measurement of angle.
And what is that 57.296 degrees, which that equates to?
Okay. So remember, like we said, that 1 feet, yeah, we know it very well. 1 feet is 30 centimeter. Yeah. So you are trying to build a connection between feet and centimeter.
Yep.
Similarly, we have two different measurement of angles. One is a radian, another is a degree. So we are trying to make connections between them.
Okay.
Right? Okay. So we started off with the circle. We talk about the circumference as 2 pi r. If you leave your r as 1 unit, circumference is 2 pi. So when you are covering the circumference, which is this part, how much degree have you traversed? That's 360 degree. Does it make sense? 360, because there are 4 triangles, as you can see. Yeah, 490 degrees. Yeah, so that add up to 360 degree. So in covering a distance of 2 pi, I have covered same amount in degree as 360 degree, isn't it?
Yep.
Therefore, 2 pi is 360. Therefore, pi is 180, or pi over 2 is 90.
Yeah. And what is that 1 radian equals?
Oh, yep. Okay, I'll explain that bit.
Yeah.
Okay, so we got pi is 180. Yeah. If you divide by pi, what is left? 1. But we call it pi is a radian measure, isn't it? So 1 radian is 180 over pi degrees. And 180 over pi is 57.296 when you divide it. Yeah.
Oh.
Because pi is 3.14.
Okay. Oh, I see.
Yeah,
Mhm. Okay.
And I have a question.
please.
Is it useful to know radian as a measurement for angles,
Absolutely.
or is it as obsolete as using feet and miles?
No, 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 no. Good point. Very good point. But no, it's utterly important. Because many instances we will refer to radian, not degrees, right? If you just think of something, it will more specifically give you answer in radian than in degrees.
Really?
Yeah, yeah, yeah,
Okay.
yeah.
I never
For
seen radian in the wild, and that's a new one for me.
that doesn't.
Neither did I.
Sorry to say this, but that doesn't prove that that's not important.
No, that's why I asked. Is
No,
it
no.
gonna be
Oh, it's
something
very good
like
point. It's
something like
absolutely good point.
miles
Okay,
and stuff? But no,
do
it's
this
gonna be
exercise.
useful.
If you are on a desktop, on a laptop, right? Try searching in your Google Chrome or whatever search engine. Just write down ARC10, ARC10, bracket 1, just like this, and hit enter. And tell me, what do you see? No, go to Google Chrome or Safari or whatever search engine or you're using. Just type in there that ARC10, ARC10, bracket 1. What do you see? Very good. Right. Now, who remembers from that memory of high school that 1045 degree? How much is that? It's 1. 1045 degree is 1. No, no, no. No, 10, 1045 degree. Yeah. I wanted to prove a point here, right? 1045 degree is 1. So when I say that 45 degree, it will be arc10 of 1. But what Google or most of the search engine does, which Austin here just confirmed 0.7 something? Yeah, 7 something, yeah. Yeah, 7, 8
Yeah, but it's in radian and not radian and not.
That's the
Okay.
point I wanted to say.
Yeah, I see it now.
They
Okay.
talk about radian. If you want the answer in degrees, the same query, you have to specify it to any search engine, ARC10 of 1, space in degrees. Just add the word in degrees. And then it will give you 45 degrees. So in order to receive your answer in degrees, you have to specify it. Otherwise, radian is a default measurement. But we, including myself, I include that, are comfortable dealing with degrees because that's what we have been seeing all our standards so far. 30 degree, 40, it makes sense. It makes so much sense to visualize in terms of degree. But it doesn't mean that radian is not important. So yeah. Right. Oh, sorry, there is some chat. Sorry for that. Okay. In a sine waves, they use radians pi rather than degree. Yes, true. True. That's one reason. I will come to that, Clifford, when we come there. Oh, Daniel has written the answer. Very good. Yeah. When you use the sine curve and everything, you say sine 4, and that will tell you, right? How long it is, because then sine and everything is not just on a unit circle that goes on XY coordinate. And that's why talking in terms of the radian, that is the real number, the XY coordinate is more meaningful than talking in terms of degree. Because if you have to plot, for example, 175 degree on x-axis, it will be hard, right? But if I say it's almost 3 radian, then you know you are going 3 unit on the x-axis, right? Anyway, I mean, you don't want to teach everything now. If it comes in the due course, I'll talk about it more. Yeah.
Sorry, I should have pointed out that he messaged. I didn't see that.
No, don't worry, don't worry, don't worry, don't worry. That's fine. That's my job to, keep an eye. No, thank you. Thanks for helping anyway. Yeah, cool. Common angles by ray density. Yes, before I move further, any doubts that I want to please shoot me with question, tons of question. I like it. Honestly, I like it because you are engaging, you are clearing your doubt, and I'm adding something which I would have thought obvious. If there is something I think you should know, then I would have said it. But I think sometimes it doesn't come to your mind. Sometimes everyone knows about it, So please keep on shooting the question. There is nothing called stupid question. The only stupid question is not asking a question. Yeah. Right, so this is some common angles by radians and degrees. So 0 is 0, pi, which is considered as 180 degree, over 6 is 30, then it's 45, 60, 90, and all that, right? We start from here, theta 1, as you keep going anti-clockwise, you got theta 2, theta 3, theta 4, and that r is the radius. You keep going. So first you are traversed up to here, come on. My pen is so funny. One second. Okay, so these are several types of angle, as you can see. Acute, that is less than 90. Then we get a right angle, 90 degree. Obtuse, between 90 and 180. Straight, as you can see it here. Straight, like this. All the covered here. Reflect angle, which is between 180 to 360. That's more than 180. So this is 180. This is more than 180. Yeah. And then we got a full turn, or 2 pi, or 360. That's what a circle does. Yeah. Okay. Convert the following into radius. What you will need this formula. 1 radian is 57.296 degree, and 1 degree is 0.017 radian. Yeah. So when you have to convert this into radians, so what do you do? 1 degree is 0.017, if I'm not wrong. Yeah. And that will be 230 times 0.017 will be minus 4.01 R. R on a power just indicates it's a radian measure. Yeah. Again, 333.25 degree times by 0.017. And that comes as 581 point, sorry, 5.81, my bad. Okay. Make sense? Convert the following into degrees. What is it? 57 point. It's here. 296. Right, two simple example to start with. Now, we go further. What if we have to break it every degree into its smaller units? right? So we have it here. 1 degree is 60 minutes. 1 minute is 60 seconds. And therefore, when you combine it, 1 degree is 60 minutes. That is 60 times 60 seconds. So that is 3,600 seconds. Okay. So
Sean,
why
I have to get going. Sorry about that. Well, go back through the lecture at a later time.
no problems, no problems. Okay, so yes, why do we have to go a bit further? It depends on the accuracy, right? Sometimes you have to be very precise in terms of degree and minute and second. Why? Just imagine Earth as a globe, like, it is a globe, but like the one you play as a kid, you just spin it around, right? If you have to point it, where is a particular city? Let's talk about New York, right? Where is New York? Now you can say it like, oh, it's around on that longitude, something like 23. Or you can say, oh, no, 25 is fine. But no, you have to be very precise, right? The 23 or 25. Now a particular location or suburb in New York, then you even go down further. Yeah. And then you talk about minute. Then you talk about seconds, even to break it down, right? So for example, I can say a particular house in New York is at 23-degree north, then this many minutes and this many seconds. So that way you are accurately, or at least more accurately, describing the location. Yeah. And this is the reverse of process, right? If 1 minute is 60 seconds, therefore 1 second is 1/60 of a minute, 1 minute is 1/60 of a degree, and 1 second, therefore, is 1/3600 of a degree. Okay, so convert the following into degree, minute, second form. Right. So we got 57.296. Let's say it's 57 degree and 0.296. We won't do anything with 57. We'll leave it as it is. In order to convert this into minute, what we do? 0.296 times by 60 minute. That is 57 degree, right? And you got 17.76 minute. Again, we split that 57 degree, 17 minutes, and 0.76 minute. We don't do anything with the 17 minute. We convert this by again timesing it by 60 seconds. Therefore, you got 57, 17 minutes, right? And 46.6 seconds. Just write everything together. 57 degree, 17 minutes, and 46.6 seconds. This is how you write them. Yeah. Let's try the next one, please. It's not in degrees, it's in radian. So first of all, convert the radian into degree and then do this process. That's the final answer for that. So what's first step you will do? Convert the radian into degree using that 57.276296. Yeah. Once you have that degree, split that, the whole number and the other number. And then once you got a minute, split it, 55 and 0.08, just split that one. So 55 is separate, and then you got 4.8 seconds. Yeah, so it's 86 degree, 55 minute, and 4.8 seconds. Cool. Can we take a quick 5 minutes break here? Right. So arc length and area of a sector. So what is it? So a sector is a piece of a circle, a portion of a circle, right? So when you're talking about this, this becomes your portion, right? So that is S. For the whole circle, we call it the circumference, which is 2 pi r. For a part of a circle, we call it sector, right? And its area is A. Now, I will connect it this way. S is r theta. What is C for the whole circle is 2 pi r. Because what is this 2 pi? When you go around the circle, you covered an angle, which is 2 pi. So technically, this is nothing but angle times radius, isn't it? Yeah. In this instance, is angle times radius as well, but we don't know the angle. It won't be the whole, it will be a part of it. Similarly, if you talk about the whole circle area is pi r square, can we write this as half times 2 pi times r square? Yeah. Again, is half times the angle subtended times r. This is the same formula, r square and theta. So this formula are derived from the formula of circumference and angle for the whole circle. They are nothing new. Okay. I'm just establishing a connection of the circumference versus the length of a sector, area of a circle versus the area of a sector, right? Okay. An example, for a circle of radius 10, find the length of the arc and the area of the sector confined by a central angle of 65. Now, please remember, this is, Austin has left. This is to confirm. How will you, okay, if I tell you, you have 5 apples in one basket and 7 apples in another basket. How many do you have in total? How many apples do you have in total?
12.
Very good. You have 5 apples in one basket and 7 pear in another basket. How many apples in total? 5. Very good. So if it was the same unit, you could add, subtract, multiply. If it is a different unit, can you add? Can you multiply?
No.
No. That's the issue we will get. So when I'm talking about, what do I need? S is equal to r theta, or A is equal to half r square theta. My r is in centimeter, which is a real number, while theta is some different system in degree. We can't multiply them, can we? Right? The same example, can you multiply 5 apple with 7 pear? No. Can you add 5 apple, 7 pear? No. Can you add 5 apple, 7 apple? Yes. Can you multiply 5 apple, 7 apple? Yes. Same unit? Yes. Different unit? No. That's why there is a need of converting this degree into radian measure, which is a real number, and therefore we can multiply real times real. Okay, that's the whole reason. Another reason we have to establish a connection of degree and radian. Right. So S is r. Make sense?
Yeah.
Sorry, I don't have the chat open. Was it Clifford or who was it?
No, I was the one. The
Ah, you
half.
get, yeah. Okay. No, I'm glad it makes sense. Okay. Right. So first thing first, convert our theta of 65 degree. How do we convert it?
I'm 0 point thingy.
0.017. Yeah, just convert it. Yeah. If you don't know this number, you can also say pi over 180. Pi over 180. Yeah. And then simplify it. So S is equal to R, which is 10 times 65 times pi over 180. And whatever that simplifies to, your S will be 11.35 centimeter. And similarly, the area half 10 square. And again, theta, which is 65 times pi over 180, and that should simplify to 56.72 centimeter square. Watch the unit, centimeter square. Make sure yes, sorry.
I have one question. How many digits of the radian we need to use? Because I have 0.017453. Do I need to use it all for conversion, or it's like by p the first 4 digits is enough?
Okay. So there is something called truncation error and propagation of error. I'll explain that very quickly, and therefore I'll be able to explain your answer rather than just narrating it. Okay. So say, for example, you will, in your mind or in the question, it says 2 decimal. So from the beginning, if you let your theta as radian 0.0174, that thing, you just pick up 2 decimal, then 0.01. Then you times it by everything else or you square it, the error will increase.
Yeah, I got that. That's why I'm
Right?
asking how far I need to go.
So go for 2 decimal at the end. Don't truncate it in the beginning. Leave pi over 180 here or extended decimals here. So when you multiply it, when you square it, that thing is still there, multiple decimal, maybe 4, 5, because you're using calculator. So let it calculate for more decimal, and then this will be 56.72 or 11.
So calculate up, and then if I have, then round up the last, so the
Yes,
round up to 2
whatever it
decimal,
says.
and that's what I'm using.
Yep,
Okay, so
yep.
not in the calculation after I got my answer, then
Keep
later
going
on.
with whatever.
Okay, okay.
In the assignment or in the exam, it should specify it either with every question or at the beginning of the exam, it should say that, oh, in your calculation, if it is not specified, go for 4 decimals. Yeah, so go with 4. It's very standard. Yeah. Good. Right. So area of a sector with the central angle 0.2 pi is 31.4559, sorry, 4159 centimeters square. What is the radius of the circle? So area is half r square theta, which is 31.4159 is equal to 0.5 r squared times theta is 0.2 pi. R square is whatever, and therefore R is 9.9999 or approximately 10 centimeter is my R. Okay. All good? Right, some angles and properties of triangles. Relationships between 2 associated triangles. So if you got 2 parts of an angle, like alpha and beta, straight here, then addition is 90. And you can say alpha is equal to 90 minus beta. Very useful when you will come to trigonometry. Conjugate angles, they add up to 360. So complementary is 90, supplementary is 180, conjugate is 360. Okay, 3 different names: complementary, supplementary, conjugate. And then finally, we got vertically opposite. So if there are 2 lines intersecting, they are called vertically opposite, right? And these 2 are called vertically opposite, right? They are same. Vertically opposite are same. Complementary add up to 90, conjugate add up to 360, and supplementary add up to 180. Parallel line and transversal. So when 2 lines like L1 and L2 are parallel, as you can see, yeah, they are parallel lines. This L is called transversal. So it cuts both the line at some point. So I create at some point, this is A, B, C, D, E, F, G, and H. We got three sets of angles that is being formed. Corresponding angles. Do we know the corresponding angles?
Yep.
Very good. Do we know the alternate angles? And do we know the co-interior angle? Corresponding angles, they are the F. There are 4 shapes of F, like this. The mirror image, the upside down, and mirror image of that. That's a corresponding angles. So angle that is placed here and here, ABF. ABF is this angle. And BCH. BCH is this angle. So you can see, I'm not drawing all of them. But as you can see here, these 2 are parallel, these 2 angles are always same. Okay, so here I talk about such a. Then the other pair will be up here, right? The third pair, I can change the pen color if it helps. The third pair is up here. This 2, right? And let me take, blue is taken green. Yeah, and the 4th pair is here, right? So these are the 4 pairs of corresponding angles. Okay, then we talked about the alternate angles. That are Z. Again, there are 4 Zs. Z, the reverse Z, and Z in terms of the N. It's not happening here, and that's why we have listed only 2 of them. And N like this. Yeah. So Z has been flipped by 180 degrees, Z flipped by 90, and Z flipped by counterclockwise 90. Right up here, we only see 2 of them. E, B, C. So this angle and this angle, and other one. Bang, bang, and bang, bang. Yeah, that one and the other one. Yeah, that's only 2 of the Z. Right. And finally, we got co-interior. Oops, I shouldn't have done that. We got co-interior angle. They are C. Again, we will have 4 types of C. C or U, whatever you call it. Upside down, sorry. Right? Here, this 2 add up to 180. And the cross add up to 180 as well. They are co-interior angle. So F corresponding alternate is Z, Z and A, like extreme end of the alphabets. They are alternate angles, and co-interior, inside angle, right? They add up to 180. In other words, you can say co-interior angles are supplementary, right? I think this is grade 7. Yeah, grade 7. This is a grade 7 math. Recently, I was reviewing maths unit, so I just was referring to all the Queensland textbook, and this is grade 7. Find the value of A and B in the diagram below and give reasons. I pause the recording, giving everyone like literally half a minute, 1 minute to think and discuss with. Right. So for A, A is 71. We call it vertically opposite angles, right? And once you have that, you can see an F here. 2B plus 5 is 71. We call it corresponding angles. So there is only three names. Co-interior add up to 180. So just keep it separate. That's addition. Co-interior because that's inside. Interior is inside. They add up to 180. Then alternate is Z. Z and A extreme end. Only one left is corresponding, right? Therefore, 2B is 66 and B is 33, and that's it. Okay, let's keep going. So we got three types of angle, right? Based on this angle, we got types of triangle. One is an acute angle triangle, obtuse angle triangle, right? And right angle triangle. Acute, every angle is less than 90. Obtuse, exactly one of them is more than 90. And right angle, one of the angle is 90 degree. Now from the sides, if all the sides are equal, right? We call it equilateral, AAA, all of them equal, AAA, all of them equal. If two of them are equal, we call it isosceles. And if none of them are equal, we call it scalene triangle. Okay. Now, a few basic properties of triangle. Sum of all the angles, we call it interior angles in a triangle is 180. Therefore, alpha, beta, gamma add up to 180. This is gamma dash. Gamma plus gamma dash is also 180. You replace it, and then you'll got gamma dash is equal to alpha plus beta. But that's an upcoming property. All the three angles of equilateral are equal to 60 because they are the same. Yeah. If the sides are same, opposite angles are same. So these are same. If two sides are same, then the corresponding angles are same as well. And this has been repeated. Didn't we say it here? Yeah, it's been repeated. Right, so this is the property I was mentioning because we know that alpha plus beta plus gamma, I'll just won't write it here, I'll write it on the side. Alpha plus beta plus gamma is 180, is called interior angle. At the same time, gamma plus gamma dash makes up 180, yeah, because they are supplementary. When you compare this two, you got alpha plus beta plus gamma is gamma plus gamma dash, leaving you alpha plus beta is gamma dash, right? So the exterior angle is the sum of the two other angles. Yeah, this is called exterior angle. Gamma dash is the addition of alpha and beta. And similarly, if you go for all the three angles, right, we call it gamma dash. Similarly, we can call it beta dash is alpha plus gamma. Alpha dash, it will be beta plus gamma. You add all of them, and that will be alpha dash, beta dash, gamma dash will be 2 times alpha plus beta plus gamma, which is 180 times 2. And therefore, it is 360. Easy proof. Yeah. Alpha plus beta is gamma dash. Yeah. Alpha dash will be beta and gamma. Beta dash will be alpha and gamma. Add them. 1, 2, and 3. Add them. Alpha, beta, alpha, gamma, beta, alpha. Everything is repeated twice. 2 alpha, 2 beta, 2 gamma. But alpha plus beta plus gamma is 180 because that's the interior angle. of a triangle. They should add up to 180. All good? Yeah. Any side of a triangle is less than the sum of the other two sides and a greater than their difference. You know what? This is a basic property of a triangle. This is how younger kids verify whether this is a triangle or not. Right? Any side is less than the sum of the other two and it's greater than their difference. The largest angle corresponding sides is the greatest side. Yeah? Congruence of a triangle. So if the corresponding angles are equal and the included sides is equal, that's called congruent, right? If a pair is called SAS, that's what we call it, side angle side. Yeah, pair of corresponding sides and the included angles. So if this two and the angle included, if this two and angle included, right? And same thing happened here. We call it the congruent triangles. All the three sides or all the corresponding angles or two of them, right? Or they are in, sides are in proportional, right? If one angle of ABC is congruent to another angle and sides are proportional, right? Then they are called similar. There's two concepts. One is called congruence, other is called similarity. Congruence is the same. Similarity is like if you wanted to draw pyramid of Egypt on a piece of paper, you try to maintain the same structure. That's a similar figure to that of the actual one. It will have some ratio. The map of Australia on a piece of paper versus the whole Australia or versus a bigger map, it's called similar, like when zoomed out, zoomed in kind of thing, right? In terms of the triangle, all the corresponding angles are equal. All corresponding sides are proportional. When I say proportional, if one angle has the side 1, 2, 3, other could be 100, 200, and 300. Yeah, that's called proportional. They are times by some constant number. Or the third condition is angle of ABC is congruent to one angle of the other thing. And the side that include those angles are proportional. So for example, if I say angle A is the same as angle A dash, A is connected between BC, right? And the other one is BC dash. They are equal to some constant K, proportional, right? Then the sides are, then the triangles are said to be proportional. Yeah, this is how the proportional triangles are represented, right? You got a bigger ABC and small a dash B dash C inside. I mean, not necessarily inside, but of the smaller size, proportional size, yeah. And this is the same thing broken down into parts if all the angles are same, right? If all the sides are proportional. So side A over side B, side, yeah, they are.
Oh, at first glance, that's a bit confusing without the picture. So no. It's just we use the gamma dash as the outside angle, and after we use the dash
Oh, no, this is wrong.
yeah. So it's okay. So it's just no. So it just means similar to the other one. It's not outside angle. It's just there you go.
This is what it means. Not the alpha, beta, gamma, ABC. When you're talking about sides, that's ABC.
No. Before the picture, we used the dash over the ABC. It doesn't matter the gamma
Oh,
or ABC.
no,
We
no, no.
use the dash for the outside degree. So it was gamma and the outside was gamma dash. And now it's just used for something else. And that's confusing.
No, no, no. I'll explain that again. I'll explain that again. What we are saying, all the corresponding angles are equal. So actually, this one should be alpha is alpha dash, beta is beta dash, and gamma is gamma dash. That's it. There is no K here. Because they're equal. They're not proportional. Right? If the corresponding angles, when we say corresponding, A with A dash, B with B dash, C with C dash, not A with C dash, right? Then that's not similarity, that's something else. Yeah? If the corresponding angles are equal, we say that the triangles are similar. Okay? Or if the corresponding sides are proportional. So when we say corresponding sides, A with A dash, B with B dash, C with C dash, right? If they are proportional, that means their ratio is constant. Doesn't matter. You could have written A dash over A, B dash over B, C dash over C. Call it some K1. Doesn't matter. But the same pattern. If you are talking about dash as a side over the regular side. Yeah. If this happens, then also we said that the triangles are similar triangles. Yeah.
Yep.
Okay. So far, so good. Any more confusions here? Okay. One more. If angle of ABC is congruent to one angle of A dash and the sides those includes are proportional. Again, this is wrong. I don't know why it's not captured. What we are saying, it's the same figure. So what we are saying, so for example, one angle is, so angle A is the same as angle A dash, right? And the sides which cover this angle, that is BA and CA, are proportionate to the sides of the other triangle. Then also we say that the triangles are similar. That's the third condition. Any question here? Oh, good. Right, we keep moving. We talk about the area of a triangle. It is half base height. Yeah, we know this formula for long, long years from primary school. Half base height, right?
Oh, something simple. Simple? I can't speak. Maybe I need to go back to primary school.
For the below given right triangles ACB and ACD, find the area of triangle ABD. Right? We are given two right angles, ABC and ACD. We wanted to find the right angle A. We want to find the area of ABD. We want to find this bit. How do you find that area? D is a midpoint located in the side BC. Let's give it a go. Right. So what will happen, as we discussed, is the bigger right angle minus the smaller right angle. That will give you the remaining triangle, right? So let's write it. I just write area of ABD is area of ACD minus area of ACB. Don't change the order of letters because the right angle has to be in the middle, right? So even though we like ABC, in this instance, it has to be ACB. Sorry, I wrote the other way, isn't it? Is B minus B, isn't it? Bigger minus smaller, right? Now, This statement is important. It says D is a midpoint, and therefore this whole A is divided into A over 2, A over 2. This is already given here, but there is a reason, why it's there. Even if this is not there, then you can't proceed. Yeah. So this is half times A times B. This is half times A over 2 times B. So half AB minus 1/4 AB, and therefore is 1/4 AB. That's the area. What is the unit here? We don't know. Just unit square. Yeah. Yeah. Because we don't know whether centimeter, meter, kilometer. Yeah. The great Pythagorean theorem. Who remembers that?
Hypotenuse.
Yes, hypotenuse.
What would the other ones? Oh no. Oh. Cosine, sine, no. Oh. And then are going back to me.
That's the butchered one.
Very good. A square plus B square is C square. Good job. Hypotenuse square is equal to the sum of the square of the remaining two sides. Right? So if you got a right angle triangle like this, I got it here. The Pythagoras theorem. So if C is hypotenuse, right, then A square plus B square, right? And then you can say A square is equal to C square minus B square. Then you can say B square is equal to C square minus A square. All of them are important. Right? Here, we are talking about alpha and beta both. In the second instance, we are talking about alpha here. So this becomes adjacent side and BC becomes the opposite side. You need to make sure you are referencing it correctly, because soon we will talk about sine cos tan. And then if you mix it up, you will get the wrong answer. If beta is here, this becomes the adjacent side and the other one becomes the opposite side, but the hypotenuse stays where it is. Yeah. Cool. Find the length of the third side in the following right triangles, assuming the same notation as above. Given A is there, B is there, C is the hypotenuse. Please find it. Thank you. Can you clear that up, please? Thank you. First one and second one. I would call it 1 and 2, so we don't get confused with A and B. A is 4, B is 3, right? So C square, which is A square plus B square, that is 4 square plus 3 square. And therefore, that's 25, and C is 5. Okay, same notation. C square is equal to A square plus B square. 25 is equal to 16 plus B square. B square is 9, and therefore B is 3. Idealistically, you should have written C is equal to plus or minus 5, or B is equal to plus or minus 3. But they are sides of a triangle. It cannot be negative, and therefore we go for 3 and 5 centimeter. We ignore the negative. Yeah. But in general, make a habit. When you take a square root, please have plus or minus. Right. Cool. Trigonometric functions of acute angles. So far, we are talking about only acute angles, right? Nothing else. Okay. Sine alpha, opposite over hypotenuse. Who remembers this? So, ka, do, a. Yeah. Refreshing your memory, SOHCAHTOA. Who remembers full form of that? Anyone remembers full form of that one? I mean, we know what it means, but there were so many ways of saying that. I forgot that. Anyway, that's not important. As long as you know SOHCAHTOA, that's fine. There was a very nice way someone taught me of saying it, but that's fine. SOHCAHTOA. What it means? S is for sign. That's here, sign. O and H. O and H. Cos. A and H. CAH. 10. O and A. TOA. Right? In our notation, we have opposite as A and hypotenuse as C. Right? Adjacent as B, hypotenuse as C. Right. This is also classified as sine over cos. Sine reciprocal is cosec. Someone write it as CSC. I've seen many other literature, they write it COSEC. COSEC or CSC, they are both cosec, which is a reciprocal of sine. SEC is fine and 40. It's only here that they write COSEC. I've seen that. Yeah. Okay. And then we got this thing here, sine square plus cos square is 1. Because what is sine? What is sine? Sine is SOHCAHTOA. Opposite, we call opposite as B or A. What do we call it? Opposite is A. So A square over C square. Cos is B square over C square. That is A square plus B square over C square. But Pythagoras told us that A square plus B square is C square. So C square over C square, and that's 1. So you got that. Sine square plus cos square is 1. Right? From here, if you make sine square as a subject, that's 1 minus sub square. If you make cos square as a subject, that's 1 minus sine square. Right? Now, for this part, sine alpha is A over C. If I want the value of alpha, the angle, that is sine inverse A over C. This is what we were, all good, Daniel, or you already left? Yeah. So this is what I was saying initially, when we say arc10, it's also called sine inverse, but arc sine, arc cos, or arc10. This is how you will type your query in the search engine, right? Okay. I already explained them here, why it is so that's fine. Right. Now, if we talk about beta, what happens? Then this becomes the opposite side, isn't it? Yeah. Opposite side of beta, which is sine B and hypotenuse, that is B over C. And that B over C is our cosec, because if this is alpha, right? Sine B or side B is adjacent of alpha. At the same time is opposite of beta as well. So they will serve two purposes, right? So what we got? Sine beta is the same as cos alpha. But traditionally, alpha plus beta plus this 90 degrees 180, isn't it? Basic triangle property, yeah? And therefore, alpha plus beta is 90. Can I say beta is equal to 90 minus alpha? Yeah. So sine beta, beta is 90 minus alpha, and sine beta is also cos alpha here. Similarly, cos beta is cos 90 minus alpha is sine alpha. Tan beta is tan 90 minus alpha is cot. And similarly, we derived all of them. Yeah. What is more important is this part. Sine 90 minus alpha is cos alpha, cos 90 minus sine, tan is cot is tan, sec is cosec is sec. In 90 minus, there is so many similar formulas which we will discussed either this week or the next. I'll give you a good chart, so don't worry about it when it comes.
What is cot?
Cos,
Cot.
cot reciprocal of 10.
Ah.
That's up here. Where did it go?
Oh, then,
And that's reciprocal of 10.
because obviously I don't really like that.
Normally in your school or high school, you are introduce only 3 of them. If you have a bit of higher math, then you introduce another 3. In university higher math, I mean, not with Bachelor of Education, but other higher maths, you also include hyperbolic cos functions.
That sounds fun.
That we don't go for that now. Yeah. Okay. Same thing repeated, nothing new there. So how do you, okay. I will come back to this. I don't want to. So there is something called solving the right triangle. So when we say solving the right triangle, that means finding the unknown. So how many unknowns are there? There are 3 sides and 3 angles. 6 elements of a triangle. But when you talk about right triangle, you already know one of the angle as 90 degree. So there are 2 unknown angles, the alpha, beta, and 3 sides, A, B, and C. So if you are given A and B, you have to find the third side and 2 angles. If you are given A and C, you find the third side and angle alpha, beta. If you are given B and C, you find the third side and 2 angles alpha, beta, right? This is known. This is to be found. And this is how you find it. Okay. The third side, thanks to Pythagoras, very easily you can get it, the Pythagorean theorem. And this one, alpha, since you know A and B, that is wrong. But you can use it, but there is a better way of it. You can also go with sine and cos. Okay, anyway, that's right. C is to be found this way, then 10 alpha is A over B. Yeah. 10 alpha is A over B, and therefore alpha ARC10 of A over B, that's called arc10, or 10 inverse of A over B, same thing. And beta, sorry, it's a typo, is 90 minus alpha. Right? Okay.
Yeah, that makes sense. Huh?
Makes sense? Yeah.
Just the last bit of the beta equals 90 minus beta. It was
Yeah.
a bit
That's a
confusing.
typo. No, that's typo. Yeah, it's alpha. Good. Okay, let's keep going. Right. If you know one side and one angle, right? How can you find it? So if you know one angle, you can straight away find the other one using this 90 minus alpha. So that's easy part. Yeah. Okay, so angle can be found. So now you know 2 angles and a side, right? You can use 10 relation, which is B over A, and therefore B is equal to A over 10 alpha. You can get your B. Once you got 2 of them, you can always use hypotenuse relation, Pythagoras thing, or you can introduce sine to find the other one. It looks a lot, but when you see the example, it will make sense. Yeah, don't worry if you don't absorb it at this very particular instance. Again, one side and one angle. If you know one angle, the other is 90 minus, so that's been found, right? So what we are doing, we are looking at a right angle triangle. Let's say this is alpha, this is beta, this is already known, right? This is what we say, A, B, and this is obviously hypotenuse, right? So you are given A, you are given this side in this first situation. I'm talking about the first situation. Yeah, you are given this A. What do we do? Beta can be found, as I said, right? We want to find the third side. what is the value of tan alpha? Is A over B. Tan alpha is A over B. Yeah. And therefore B is equal to A over tan alpha. You know A, you know alpha, plug it in here, you will get B. Once you know your A, once you know your B, hypotenuse is C square is equal to B square plus B square. So you know the third side as well. Does it make sense? 100%? Clifford and Weber, does it make sense?
Yeah, all good.
Perfect. 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 Awesome. Good. And similarly, you can talk about the other situation. Yeah. What you must remember, even the formula sheet will be there. You can carry any printed or handwritten literature, but you still need some basic information absolutely clear in your mind, right? Because if that happens, then you can easily connect with it and think about it. Yeah. Again, same information. I'm not going with that. Find the unknown length in the following. It specifies 2 decimal. Give it a go. I think that looks right. Yes. Cool. So here, we already got a couple of tables on how to navigate and all that, right? If you have to find the unknown side, keep it very simple. What do you know? You know one angle. You know this side, which will be called the opposite side. And this is hypotenuse. Which trigo formula will connect opposite and hypotenuse? Sine, SOH, SOHCAHTOA. So we got opposite and hypotenuse in sine. So write down sine 67. That is opposite over hypotenuse. Opposite, which is x, hypotenuse is 12.8. This is sine 67. Sometimes you have to make sure your calculator that you use is set in proper degree format, not in radian format. Otherwise, you will get up some error, right? And that one is 11.78. Yeah. X is 11.78. Okay. You won't be able to absolutely check it, but across reference, 90 degree opposite side is 12.8. So 67 has to be less than 12.8. So 11.78 kind of verifies that fact. Right, over here, we know an angle. We know the adjacent side. We wanted to find the opposite side. So adjacent and opposite. Adjacent and opposite is 10. So 1039 is opposite over adjacent. Is x over 8 is 1039, right? Therefore, x is equal to 8 times 1039, and that will be 8 times 1039, and that is 6.48. That's what we got. Thank you very much. 6.48 meter. Now, please be careful with the unit. Up here, it talks about centimeter. Answer should have centimeter. Here, it talks about meter. Answer should have meters. Yeah. Good job. Good job, everyone. Give this one a try. Okay. Let's do it. I'll do it silently so those who are doing can continue doing it. Cos is adjacent over hypotenuse. Adjacent is 6.2, hypotenuse is x. This is cos 52. X will be 6.3 over cos 52. So once you put that thing in your calculator, 6.3 divided by cos 52, that comes as 10.23. Correct me if I'm wrong. Centimeter. We are given an angle. We are given the opposite side. We are given the hypotenuse. It has to be sine. Is opposite. I'm just writing the formula so you become used to with it. You don't have to write the formula. We'll divide by sine 35, and that is 20.92. Is it right? Yeah. 20.92. Yes, good. Thank you. Measure of the angle. Let's try that one.
So it's and just like
10 inverse. 10 inverse. 40.9. Yeah. What is next one? Cos inverse of 2.7 over 5.2. $58.72. That one is not. The first one, isn't it 35.54? Arc10 of 5/7. Give me 1 sec. Yeah, so theta is in the first instance, arc10 of 5/7 is 35.53, and the second instance is 58.72. Okay. In the triangle ABC below, A is 45, that's up here. B is 12, this side is 12. C is 10. The whole side is 10. Solve this triangle. What is the area of triangle ABC? By solving a triangle means finding all the unknowns. So please give it a go. So in this triangle, there are so many unknowns. We know 3 values. What we don't know is small h. What we don't know is this AD. And from AD, we can find out CD. We don't know small a. We don't know angle B. We don't know angle C. So many things to find out, right? We can start from something very easy. Okay, so let's talk about, this is the angle. I know the hypotenuse. I don't know the opposite side, right? SOH, right? We'll take care of it. So for triangle ADB, sine 45, opposite, that's BD over AB. Therefore, BD is AB, which is 10 times sine 45, which is 1 over root 2. And therefore, that will be 5 root 2 is how much you said? 7.07. 7.0, come on. 7.07. No units given, so units, yeah? 7 points, that's your H. Right? Now, you can use further trigo, or you can simply say that triangle ADB is isosceles triangle because it's 45, that one is 90, so the one has to be 45. So 2 sides are equal. So this one and this one are same. Therefore, H is the same as AD, is the same as H or BD, whatever you say, it is the same as BD 7.07. So I got my BD as well. Therefore, CD will be 12 minus 7.07, and that will be 4.93. That's my CD. Right? So I got a couple of them. What I got 7.07, that's one of them. I got 3 of them. Right? So I got this side. Okay. I got H. I got this 90 degree. Right? What else can be done? I can find A with the help of hypotenuse Pythagoras theorem. So A square is equal to A square plus CD square. That's a right angle triangle here. I'll use some different color. That's a right angle triangle here. Okay, so A square is CD square plus H square, right? From there, A square will be CD, which is 4.93 square, and H square is 7.07 square. That will lead me small a is equal to 8.62. I got my small a as well. So I got small b is given, small c is given, angle A I have found. I just need angle B and C. That's what is left. Okay, so what I will do, triangle BDC. Triangle BDC. I know my hypotenuse. I know the opposite side. So opposite over hypotenuse. Sine C is equal to BD over BC. Therefore, sine C is equal to sine C is equal to BD. BD is H. H is 7.07 over A. A is 8.62. And C will be sine inverse of that thing, that is 55.3 degrees. I got my capital A, I got my capital C, and capital B will be 180 minus A and C, and therefore capital B will be 79.70. So I got my B, I got my C, I got literally all the unknowns. Right? Okay, any questions? All good online?
Yeah, I'm just slower.
No, that's fine, but you understand everything, yeah?
I got up to I have all the sides, so now just for the degrees that I'm missing. But
Okay. Right. Okay. Let's keep going. Oh, what did we miss? Did we miss the area, isn't it? We missed the area. We didn't find the area. And that's why this is there. I said, wow, okay. I needed more space. Yeah. So area. Area is very easy, isn't it? Area of
just
triangle.
do the two right triangles and then add them together.
How about half bit height, isn't it? That will be really easy. You can do two right triangles. Or you already got the height. Yeah.
Oh yeah.
So, that is 12. And H, what is H? Is 7.07.
7.07.
Very good, thank you. 7.07 times 6, 42.42. Yeah, again, no unit, so unit. That's the area. Had I known that I had more space, more slide, then I wouldn't condense it so much here. Anyway, it's still readable, but yeah. One more slide. There you go. Use it. Use it. Okay. Next question. An 18-meter guy wire supported a pole form and an angle of 29 degrees with the ground. How far is the guy wire pegged from the base of the pole? Think about it, draw a figure, apply some trigger thing that you learned.
It's a guy wire.
Just a wire.
Oh,
It's a type of the wire, as we say, so it's just a wire. There is a pole. Oops. (29 degrees) with the ground. How far is the wire pegged from the base? So you want to find this. And 18 meter is here. Give some nice name A, B, and C, where AC is the wire, right? You want to find out BC. That's it. Ask yourself, what do you know? I know an angle, I know a side. In connection, what is this? This is adjacent. And sorry, my bad. Adjacent to be found. This is hypotenuse and adjacent to be found. Which trigo will connect adjacent and hypotenuse? Ka.
oh,
Ka. Yeah. So cos, that's what you did, right? Yeah. Cos 29. Yeah, that's what he did here. Cos 29, but still the answer is not right. 20.58 doesn't seem right. Cos 29 is SOHCAHTOA, adjacent over hypotenuse. Adjacent, we don't know, that is BC. Hypotenuse is 18. Cos 29, right? Leave it as it is for now. Therefore, BC is 18 times cos 29. Let me do it on the calculator. Okay, 18 times cos 29. And that comes up as 15.74 meter is how far. So then write it down because BC is your notation. Someone would have taken X, Y, Z, someone would have taken PQR, right? The wire is at 15.74 meter from base. Okay. Clifford, I would quickly say your answer is 20 point something. It's not right. Remember what I said? 90-degree opposite side is 18. So obviously all the other two side has to be smaller than 18. So if your answer is more than 18, can't be right. Can't be right. If it makes sense. Yeah. Bigger angle, opposite side is bigger. So 90 is the biggest angle. So its opposite side or hypotenuse is the biggest side. Right? So if that's 18, that means the other two side has to be smaller than 18. So if by any chance you get more than 18, that's something wrong. Yeah. Right. A tourist slides 24-meter down, new straight water slide. The slide begins 15-meter above the ground. What is the angle slide makes with the ladder? Think
I
of.
almost didn't realize that was a new question.
Oh, that's a new question. Yeah, sorry.
So when I write down the stuff, is it fine if it's not like arctangle or arccodes or whatever? Is it fine to just do like close to the power of -1? Because
Yeah. It's perfectly fine. Yeah. It's called cos inverse. It's fine. Yeah, cos inverse sine is fine. Right. So we got a slide AC, we got a height AB. What we need is this angle that slide makes with the ladder. Yeah, so ladder is straight in this instance. Yeah, it's just going up. Okay. Right. All good?
Yeah.
Okay. Ask yourself, what do we know? We know the adjacent, we know the opposite, right? So again, cos A is equal to 15 over 24. A is equal to cos inverse 15 over 24. Yeah. Inverse. Cos inverse 15 over 24. 51.32.
Yeah.
That's the angle. Right. One more. There are two more actually. You draw a ladder, you draw a wall, The foot of the ladder is 4.2 from the base. So you have that information. Ladder is up to, this, when it touched the wall is 8-meter high. What angle? That is the angle that it makes, right? What you think, you wanted to find the angle. What you know is the opposite side. That's what you know, right? This is the opposite side. We know the hypotenuse. So, ka, to, right? 10. Sorry, my bad. This is adjacent. That's why. Yeah, TOA. So opposite and adjacent. They will be connected with the help of 10. Just find out 10 inverse or arc10. Okay. Okay. Right. And I think is a final example. Think about it. Give it a go. See, drawing a figure is very important, accurately. Yeah, anyone can do it, but accurately, right? So let's start it. Let's absorb the information. A beacon is mounted on top of a tower that sits on a vertical cliff. So there is a cliff, there is a tower, and there is a beacon, right? Okay, so let's start with a cliff. So that's the cliff, right? On top of the cliff, we got a tower. So let's say this is a tower. And top of the tower, what do we have? We have a beacon, right? So that's the beacon sitting there. That's the tower, and that's the cliff, right? Now, the beacon is 35 meters higher. So that one is 35, isn't it? Right? To an observer at some distance from the base of the cliff. So you draw a base. There's an observer here, a bit far. The observer is making two observations. How do you know two? The beacon and the top of the cliff. So that's the top of the cliff and that's a beacon. 35 and 25. The smaller is 25. The larger is 35. Now this additional 10 degree doesn't help you because that triangle is non-right angle triangle. Doesn't help you. Let's call beacon is there. Let's call it A. Let's call it C and D. Right? I call cliff as H and this as X. Yeah. So for right angle triangle DAC, what do we got? 10, 25 is H over X, right? And therefore H is X 1025. Whatever that is, don't worry about it now. For the whole triangle BAC, 1035 is H plus 35 over X, isn't it? H is there, 35 is top of. So the whole height is H plus 35, right? So X 1035 is equal to H plus 35. Am I mixing up? No, it's 35 everywhere, so don't worry. Angle is also 35, height is also 35, so, right, that's how the question is. Now replace the H value. X 1035 is equal to X 1025 plus 35. And now you solve it, right? And now you solve it. Okay, so let's go for 1035. That's 0.7. So 0.7x 1025. 0.47 plus 35. Why would you say 60 degree? There's nothing here that says it's 60 degree. No. Doesn't add up. The reason is from the same point, he's making observation to two different height. So that doesn't add up. No. Okay. Right. So 0.7 minus 0.47. So 0.23. Yeah. 35 divided by 0.23. And that's, yeah. Once you solve it with all the, I mean, like I said, the more decimals you keep here, the better your answer will be, right? So on solving it, you will get your x as 149.64. So how far is 149.64 meter? Make sense?
Yeah.
See, I only written 0.7, but you should write 4 decimals here. You should write 4 decimals here and then subtracting, then your answer will be more accurate. Yeah.
Exactly. Put in some substitution because I was just thinking, how?
This was a good question. Perfect. That's it, guys. So thank you very much for coming in, staying so far to me or watching me online. And I will see you next week. Take care until then. Thank you.